Assalamu alaikum. Today is the 41st lecture of Software Requirements Engineering. And as I had mentioned in the previous lecture, we will take up interesting selected topics for discussion from now on till the end of the semester. Today we are going to talk about Agile methods and requirements engineering issues for Agile methods. First of all, we need to talk about what are Agile methods. Agile methods are basically those software engineering methodologies or software engineering approaches which address smaller software life cycles, and they can be considered as processes which are always changing, processes which can be adapted more easily than the traditional software engineering processes. The agileness, the fluidity of the software development is being addressed in these approaches, in these methodologies. These methodologies have become fairly popular in the last decade or so. There are a number of Agile methods, and their use is increasing all over the world. And so this is an area which really cannot be ignored by any particular subjects, especially as it relates to requirements engineering, because requirements engineering has a fundamental role to play in the development of high quality software. Today what we will do is we'll talk about Agile methods, and we'll see what are different issues in Agile approaches or Agile methods, and then we will see how these methods address the requirements engineering issues, and in particular requirements elicitation and management issues, because that's what really is the focus of Agile approaches. Agile methods are a family of software development processes. There is not one particular Agile method. There are a number of Agile methods. Their aim is to deliver products faster. So one thing is that they claim that products developed using Agile methodologies are developed quickly as compared to the traditional software development approaches. Another claim is that the quality of software is high. Similarly, they claim that customer satisfaction is higher as compared to traditional approaches, and we'll talk about why this is so. And customer satisfaction is addressed through the elimination of waste, and through a concept which is known as lean production, and how lean production is applied in software development. And we'll see in a minute what lean production is and how we can eliminate a lot of waste in our processes for software development. So again, the focus is on rather quick or faster development of software with high quality and with lot of emphasis on the customer involvement and customer satisfaction. Lean production is also, as I mentioned, an important part of Agile methodologies. Lean production has been conceived during the 1950s in Toyota Motor Company in Japan. It involves several practices that are now part of most manufacturing processes, such as just-in-time development, total quality management, and continuous process improvement. These practices are basically used in manufacturing industry, particularly just-in-time principles, with the availability of very reliable courier services and very reliable warehousing, off-site warehousing mechanisms. It has become fairly popular to not store the required parts in a factory or close by a factory, and just make them available just in time when they're going to be used. Now, what happens with this approach is that a lot of money is saved by not having to store these large quantities of different parts that are necessary for the development in the manufacturing process. And since factories are already crowded and they are fairly large and occupy a large physical space, so once you don't have extremely large warehouses with them and you don't need to store these parts on a permanent basis, you'll cut a lot of waste and you sort of operate in what is known as the lean production mode. And so also the continuous process improvement has been a very important goal in all the industries, including software development. And we talked about that as far as requirements are concerned in the earlier part of the semester. And also total quality management has been a very important aspect of not only the manufacturing industry as a whole, but also in software development and other management aspects. So all these principles originally came from different parts of the world, and there are a number of different approaches being practiced in different parts of the world. And so what we need to do is to look at which practices are applicable to software development and which practices are not applicable to software development, and pick those which make sense and are relevant as far as our profession, as far as our application areas are concerned. The principle of lean production is the constant identification and removal of waste. So what is waste? Waste is anything that does not add value for the customer to the final product. And this is a very different approach from our traditional software development methodologies. And we'll talk about this in a little while. But let's concentrate on this concept a little bit more deeper. What is lean production? Lean production is constant identification and removal of waste. Waste is something that is not needed by the customer in the final product. So anything that is intermediate, anything that is probably needed by the development side, by the development team, is considered waste and probably need to be first identified and then removed as part of the development using agile methods. Now, agile methods focus primarily, with this concept of lean development, primarily they focus on delivering value for the customer, because their entire focus then shifts from process of development to the customer's needs. So the first thing is they focus on delivering value for the customer. And second thing, which is very important, is that ensuring that the customer understand such value and be satisfied with the project. Now, if the development approach is focused very heavily on delivering value to the customer, and customer does not fully understand or appreciate the value that's being given to him or her, and then also being not satisfied with the product or the project, then that kills the entire purpose of agile development. Because the agile development, as I've said before, involves focus on quality, involves faster delivery of software product, and also the fact that customer needs to be fully aware of the value that's given to the customer and appreciate that. Agile methods pose a lot of emphasis on producing and delivering to the customer only those features that are useful. Now, this is a stark departure from our traditional software development approaches, where a lot of emphasis is being given to the fact that a reusable architecture is being developed, and that architecture is given to the customer. And there are a lot of intermediate products that are developed as part of the software development effort. Producing anything that is not required is considered a mistake in agile methodologies, in agile approaches. So this is one of the very important and significant differences from our traditional software development methodology, software development approaches. And this is something that all of you need to understand and appreciate, that why agile methods are different from other methodologies. Adding a feature that is not needed only consumes effort without adding customer value. So thesis is that once you start adding features that are not needed by the customer, but you have to add them, is not going to provide any value to the customer, but it is going to create extra code. And so that code may include errors, and your overall code of the program will increase, will become longer, and will be more complex to maintain. It may be difficult to correct and to improve. And accordingly, you may have to produce some more documents with it, design documents, which are not giving value to the customer with the view of this methodology, obviously, because the traditional approaches a lot of emphasis on the development of these design documents. Now, the ways that we have talked about include these architectures, include these design documents that are not used or are only partially used, or are reusable components with functionalities which are likely never to be used in this particular application. The emphasis of agile methodology is on today, is on developing software which meets the needs of the customer today. That is the current needs. It does not emphasize on looking beyond a very near future. And so the emphasis that the traditional software development methodologies have is that you need to address the future concerns, the future possibilities of the customer's needs, and make that part of the framework of the software that is being developed. That approach is different from the agile approach. The agile approach basically focuses only on today's needs of the customers. And to achieve this elimination of waste, agile methods claim to be adaptive rather than predictive. That is, they adapt their processes according, or their methodologies according to the changing needs and changing requirements of the customers. And also, these methods are people-oriented rather than process-oriented. And so the focus is on developing skills of the people rather than spending too much time and energy and resources on developing processes, which has been the more focused approach taken in the traditional software development life cycles. Also, when you have a people-oriented approach, a close collaboration between development team and the customer is a must, so that the requirements are fully identified and correctly understood. There is again a very important thing to be remembered, and that is that the delivery of products is in a shorter cycles and smaller iterations and smaller increments. So it is very important that the requirements are fully understood by the development team, and the final products reflects what the customer needs, no more, no less. It is very difficult to demonstrate no more part of this equation. And so again, the focus is on the current immediate needs of the customer, no more, no less. There are a number of agile methods, and I'll just name a few of them and move on. We don't have time to talk about each of them because we would like to focus on the requirements engineering aspects of overall aspects of these methods. Number one is the extreme programming. This has been become fairly popular, and a number of books have been published on extreme programming. Then there is Scrum. Third is dynamic systems development methods, followed by adaptive software development, and finally the Crystal family. There are others, and they are increasing agile methods, and there is a lot of interest in the software development community to play with these methods and to find ways to develop software in new and creative ways. The manifesto of each of these agile methods is that individuals and interactions are preferred over processes and tools. So, as I said before, that these methods are more people-oriented rather than process-oriented. So, individuals and their interactions are preferred more over the processes and tools. Number two, customer collaboration is given preference over contracts. So, there is a lot of interaction that goes between the development team, and in fact entire development team, and the customer, as compared to written contracts. There is preference to working software over documentation. And finally, responding to change is, or response to change, shall I say, is more important than planning. So there is planning obviously for one build, but planning for future is not as much of an emphasis in agile methods as the response to change is emphasized. That whenever there is a need to change, whenever there is a change in the requirements, whenever there is a change of team, whenever there is a change, you need to respond to that change, whenever as compared to spending a lot of time on planning activities. So these are the different things that make it distinguished from the traditional ways of software development. What are the common practices and behaviors? Adaptability. Whenever you are going to have to respond to change, you need to continuously adapt. And also, whenever you have people and giving preference to people over processes, so adaptability of processes, adaptability of people to accommodate change, the ability to incrementally develop software. So that's a very important common practice, incremental software development. Frequent releases, as I just said, that you have shorter life cycles and you are giving increments more frequently. Also very important is requirements prioritization before every iteration. Which requirements will be included in which increment, or is an important part, is an important enough thing to be discussed before each iteration begins. And there is high customer involvement. This is a very important. Agile methods cannot work, and they will not work if there is any reservation on part of the involvement of the customer. And we'll see what kind of customers these approaches have, and also what kind of authorities these methods require a customer to have. Coming back to our very interesting topic, that is the requirements engineering in agile methods. The whole development team is involved in the requirements elicitation management. Now, this is a fundamental shift from our traditional approaches to requirements engineering, traditional approaches to software development. Traditional approaches, only a subset of the development team is involved. And even if you look at larger development efforts, there is a specialized requirements engineering team, as we have talked about earlier in the semester. And its job is to basically execute the requirements engineering processes. And yes, they do work with the development team, and overall they are part of the development team. But specifically, if we concentrate on design and development, requirements engineers work with the development teams. But it's rare that the developers work with the customers. But here in the agile approaches, the entire development team, that is the software writers, code coders, programmers work with the are involved in the requirements elicitation and management, and this is a fundamental shift in paradigm as far as our approaches to software development is concerned. Now, this approach is feasible only if the size of the problem is limited, as only a small development team can interact directly with the customer. If you have, let's say, 150 or plus programmers working on a product, the impact of all of them working together with the customer is phenomenal, and it's very difficult to manage that sort of thing. So the size of the problem limits the application of agile methods, and so if the problem is bigger, the team can use other techniques for elicitation and management of requirements, and one can still apply maybe agile methods, but only authorize a limited number of people from the development side to work and collaborate with the requirements engineering. And so you see that the continuous you see that the continuous involvement of the customer is a must. However, we may have to limit our development team to make contacts with the customers. The understanding of requirements variability has a strong impact on the ability of agile methods to be lean. This is because that the requirements vary, and if you do not understand their variance and we don't manage the variability of the requirements, then the concept of the lean production becomes difficult to manage, and this lean production is one of the key aspects of agile methodologies. If the requirements are continuously changing so that the variance is not known or is ambiguous in that, so in that case it would be difficult to remain lean as far as the production of the software is concerned. Now, the focus of agile methods in requirements engineering is primarily on four things, or we can say that these four things that you see on the chart are important enough to be considered as part of agile methods and requirements engineering. Number one, the customer. Number two, waste in requirements. Number three, requirements evolution. And number four, non-functional requirements. And we'll see each one of them in a little bit more detail. So let's talk about the customers and requirements engineering for agile methods. Customers or stakeholders assume a paramount role in requirements engineering in agile methods. The interaction between the development team and stakeholders is complex due to the different perceptions of the problem that these stakeholders have. And so one of the things that we talked about in when we were talking about agile methods was that there's a lot of emphasis on the interaction, and the entire development team is involved with the customer. And if the customers have different perceptions about the products, then you can imagine the problems that the development team will have in trying to understand and to clarify what really the requirements are. And so the problem of multiple stakeholders is solved by reducing the customer to only one, who represents all stakeholders in a project. And this can be then very useful and very helpful in actually understanding and clarifying the requirements for the development team. This can also add problems to it, and the customer, who's the representative of all the stakeholders, must fully represent the views of all the stakeholders. The customer should be a domain expert and be able to make important decisions such as accepting the product, because that's very important, prioritize the requirements, and clarify the requirements to different team members on the development side, because they will come to that customer on a regular basis, on a daily basis. That's what this approach is all about, involving customer in day-to-day efforts of the development of the product. So the customer must be available. That is the customer on-site requirement, that this customer has to be working with the development team on premises, on campus for the development team. Availability, the customer has to be always available to answer questions coming from the development team. Any delay in the answer delays the development of the product. Again, this approach, this way of developing software is very different from our traditional software development processes, software development life cycles that you all know. Complete knowledge must be attained by that customer. A customer must be a representative of all stakeholders, as I said before. Therefore, he is able to answer all the questions since he is the domain expert and knows how the application works and what kind of data is required and what kind of data is produced. Again, this is possible only if the size of the project is limited. One person cannot be able to completely understand all aspects of a product if the size of the product is very large and the product is very complex. Another thing that the customer must possess is the decision power. The customer must be able to make final decisions and commitments. Changes in requirements, acceptance of the features of the implemented product can be decided directly by the customer because the customer is available on site with the development team. And this approach allows a very quick and very fast decision-making process. This is a great benefit of the Agile methods, that the customer is available with the development team, makes the decisions on the spot, can prioritize requirements, can clarify requirements, and so any questions, any problems that the development team has will be resolved fairly quickly because of the decision power, because of the availability of the customer to the development team. So Agile methods cannot work if customer is not very deeply involved with the development work. Now, the second thing that we talked about was the focus on waste in requirements. So let's consider that. What is waste in requirements and why is it important? Identification and reduction of waste from requirements assume again a paramount role to avoid the creation of waste later in the development cycle. If we eliminate waste in the requirements engineering processes, then naturally that waste is not going to create more waste, and as a result we'll have that what is our basic principle of lean production, and we'll apply that and we'll benefit from that approach. In lean practices, the reduction of waste is extremely important because waste always generates more waste, because if there is a problem, it's going to lead to more problems. If there is a dead code in the software, it's going to lead to other problems, maybe testing errors, and if there are errors in the requirements, it's naturally going to create errors in the design and the development work. So elimination of waste in the requirements is certainly going to help us in elimination of waste down the development cycle. Waste in requirements include both wrong requirements and useless requirements. Now, these are two different things. One is wrong requirement, which must be corrected immediately, but also there are useless requirements. In our traditional approaches, we can have some of these useless requirements as features or possible features for the next version of the product, or we can have them as feature gimmick, while we include things in our software product which do not really belong there but are just thrown in for the customer to use them and to play with them. This is not allowed in Agile approaches. This is not acceptable in Agile methods, and anything that is useless has to be eliminated because it is considered as waste. And both of these types of waste, if eliminated in the requirements activities, will then certainly enable us to carry on with the lean practices in the development work later on. All the waste generated is a cost for the customer, both directly and indirectly. That's a fairly easy to understand concept. Whenever there is something for which the customer has no value in the final product and that thing is produced, then obviously it takes money and it takes some bit of cost to develop that feature. And such costs are likely to generate further waste inside the customer organization due to the reduced amount of money available to its core businesses in reduced revenue. So not only that the waste generates more waste, but also that the money spent on creating such waste is going to limit our work and will limit our development activities, because the money is already spent and we may be left with short of funds or scarcity of funds to complete rest of the project. Now, the impact of waste on requirements and the development process: more source code to write and higher cost. As we said just before, that if we have waste in the requirements, then we end up writing more software, end up spending more on things which are not going to be useful for the customer. We will end up increasing the complexity of the software, and one can understand it very easily that if a software is more complex, particularly that software which is not going to be used by the customer, can have a number of negative effects on the overall value and overall quality of the software product. This will certainly result in the delayed delivery of the final version of the application with all functionalities, because we are spending time and we are spending money and resources on things which are not needed by the customer. And whenever we have complexity, we are certainly going to spend a lot more time and a lot more money on maintenance of such piece of software. And so more resources are required by the application, including computer resources like memory usage and processing power and network usage and so forth, which are really not, again, not needed by the customer, but just put into the product as a feature gimmick and not needed by the customer. So we need to find that waste, we need to eliminate that waste as early as possible so that it does not go into the programming practices. Increased complexity of the application from the point of view of the customer, that is more complex user interface, more effort to learn how to use the application. Earlier we have talked about the complexity as far as the maintenance is concerned, but now consider the complexity as from the customer's point of view. So considering that, if there are some requirements which are related to the user interface and are not real requirements of the customer and they become part of the final product, in that case it is difficult for the customer to use the product and the user interface itself becomes a problem. Another thing is that the savings produced by the application in the production process of the customer are delayed. And so not only there are maintenance issues, usage issues, but also cost issues which are produced because we have not eliminated waste in these requirements engineering processes using these methodologies. Now let's talk about the interaction with the customer for a little while, because that's very important. Techniques that force us sort of to focus on the interaction with the customer. Number one, we have said that the whole development team collects requirements from the customer. And so this approach eliminates the usage of documents to share knowledge, or it minimizes them substantially. In our traditional requirements engineering approaches, we emphasize a lot of knowledge gathering from documents. So very little emphasis on studying of documents for the development team. Second is the requirements are collected using common language, and requirements are collected using the language of the customer, not any formal language. And in our traditional approaches, we do use different kind of structured languages for requirements documentation. So the emphasis again here is on the interaction with the customer, things that the customers understand well and things that they can communicate with. And so direct interaction between the development team and the customer reduces both the number of documents required and the probability of misunderstanding due to unnecessary communication layers. If we have multiple documents and different terms are used in different contexts, and so there's a possibility for the developers who are really not domain experts to misinterpret different terminologies. And another technique that is important in customer interaction is the requirements splitting, that if the development team consider a requirement too complex, this technique helps the customer to split it in simpler ones and with the help of the customer. Again, the emphasis is on continuous interaction of the development team, entire development team, with the customer. In order to reduce waste created by the over-specification of requirements, following two techniques can be used. Number one, requirements prioritization and incremental releases. And we have talked about both of these things. Requirements prioritization is taking up or finalizing requirements for one increment and reducing the delivery schedule, and so having more increments, more incremental releases, and implementing fewer requirements in each cycle. The prioritization activities include that the development team estimates the time required to implement each functionality. If the effort required is too high, the requirement is split to two or more requirements so that they can be implemented in a shorter time scale. The customer specifies the business priorities for each functionality. So this responsibility lies with the customer and not with the developer, because customer is always available. And according to these business priorities, the development team assigns a risk factor to the functionalities. The customer and the development team identify the functionalities to be implemented in each iteration. Again, this can only be done if the customer is available on site and working alongside the development team. The third concept that we talked about was the requirements evolution. Agile methods assume that it is very hard to elicit all the requirements from the user upfront at the beginning of the development project. And this is not only Agile methods. In fact, all the traditional methods also assume that it is very difficult to understand and to elicit all the requirements, complete requirements, at the beginning of the project. And so all approaches provide mechanisms to iteratively go back to the customer and gather more requirements and sort of analyze and negotiate those requirements iteratively. However, the emphasis in the Agile methods is that you don't even need to try to collect as complete a set of requirements as possible. These methods also assume that such requirements evolve in time, or that is, all requirements evolve in time as the customer may change his or her mind, or the overall technical or socio-economic environment may also evolve. And so there's this underlying understanding, underlying hypothesis that we don't even need to make an effort to completely understand the requirement. And that is the difference between the agile methods and other traditional requirements engineering approaches, because in traditional requirements engineering approaches, we do at least try to get a substantial set of requirements which are consistent and are stable. Agile companies are aware that changes are inevitable, and they include the management of variability into the development process. So whenever you are developing software using agile methods, there is this ingrained training sort of that goes on as part of the development exercise, that change is inevitable, and we need to evolve our development strategies as the changes become clear and as the changes take effect, so to speak. And so this has really become a part of the way business is done. Requirements are not well known at the beginning of the project. This is a very well known fact, particularly for agile methods. Requirements change, that is another fact. And finally, making changes is not expensive. Now, this is something which is again new, or I would say different from the traditional approaches, because in traditional approaches we do talk about the fact that making changes is expensive, and this hypothesis, that is making changes is not expensive, is not always true, and one can find empirical evidence and statistical evidence to back this statement up. However, agile methods assume that the cost of introducing changes in a product is nearly constant over time. However, this hypothesis is not true in every context. Usually what happens is that the cost of implementing changes grows exponentially over the time. On the other hand, if the development processes, development activities are grouped together in short iterations and binding decisions are taken as late as possible, the growing of the cost is limited. That is, two things are said here. Number one, that there are shorter life cycles, and then binding decisions are not made earlier in the life cycle. What happens is, most of the time, as involved with the expense, that if the binding decisions are made earlier in the project, then to make changes that affect those binding decisions is certainly going to be expensive. Now, if we have shorter life cycles, the development costs will remain the same in each life cycle, and if the binding decisions are made later in the project, the impact of making changes cost-wise are not going to be that punitive. In order to manage requirements evolution, agile method use what is known as variable scope, variable price contracts. This means that the features really implemented into the system and its cost evolve as well. So the features also change, and also the cost of the product will change, will evolve as the development is continued. Now, this can only happen, again the emphasis is that this can only happen if the customer is available on site to make the decisions that are necessary to be made, that must be made for inclusion of different features, of inclusion of requirements in product. And the same point is again discussed here, that the requirements are negotiated throughout the project between the customer and the development team, and that can only happen if the customer is available and is working alongside the development team on the site where the development work is being done. Manage requirements variability has two steps. Number one is decoupling of requirements, and number two is requirements elicitation and prioritization. Now, what is decoupling of requirements? Requirements have to be independent as possible in order to clearly identify what to implement and to make the order of their implementation irrelevant. Now, this is very important. And the second thing in managing requirements variability as the activities of requirements elicitation and prioritization before each iteration. Before every iteration is started, there is requirements collection and prioritization activity. During that activity, new requirements are identified and prioritized. This approach helps to identify the most important features inside the ongoing project. And one more thing, that is, the features are implemented mainly according to the prioritization and not their functional dependence. And this is a departure from our traditional software development approaches. The last thing that we emphasis on requirements engineering in the agile approaches is non-functional requirements. Agile methods do not provide any widely accepted technique for eliciting and managing non-functional requirements. Such requirements, that is the non-functional requirements, are collected implicitly during the requirements activity, during the requirements elicitation activity, and the need of specifying non-functional requirements is less important than in other contexts due to continuous interaction with the customer. The customer is continuously working with the development team, and so there seems to be no special emphasis given to non-functional requirements because customers can clearly see where the product is going, and if they want any changes made, they'll do that immediately, especially in the next iteration. And so the emphasis that is laid on the non-functional requirements in traditional requirements engineering approaches is not given due importance here. And so there are three things, again, three roles that are very important. The customer plays its roles, and we have talked about that role throughout the lecture today. Then there's a role of developer who's continuously working with the customer to fulfill the requirements and developing projects. And then lastly, there's role of managers who are responsible for this mutual harmony in the team, development of activities, the availability of resources and time management, and all the other activities, the schedule and so forth, and making sure that developers do finish their work on time, within budget and on schedule. And so these are the three things, three roles that people play when they use agile methods. We'll talk about the tools for requirements management in agile methods. Number one, and it's very interesting, is that the first set of tools is paper, pencil, and pinboards. Then you can use UML modeling tools, and we have talked about them in quite a bit of detail even in this course. Then there are requirements negotiation tools, instant messaging tools, and project management tools. These are the typical tools, but the first one is very interesting, still considered is a pinboard or a whiteboard, and that can be very effectively used in the agile methods also. Because customer is always there, you can have a discussion many times a day, you can get a clarification about different things in multiple times a day, and so the availability of customer really can make these methods very, very successful particularly for small to medium-sized projects. Today we have talked about agile methods and their approaches to requirements elicitation and management. These methods are still evolving, and a lot of interest is being shown in research in the methods themselves and different aspects of software development that are associated with these methods. But one thing is a must, and that is the customer involvement. Without a committed customer involvement, these methods will not produce the results that they claim to do so. Next time, we'll talk about yet another interesting topic. So, see you in the next lecture. Thank you.